Hi there, welcome to the history class. Today's class we're looking at mathematical induction. Now, mathematical induction as it were has been brought into mathematics to prove that the formulas attached to each series is correct. Now, how do we prove that? In mathematical induction, we prove that using three basic cases, or looking at three basic cases in that case. Where the first one is what we have to prove for our P of n, which is equals to P of 1 to be true. Number 2, we have to prove that what our P of n, which is equals to P of k, is assumed to be true. And also we have to prove that what our P of k plus 1 is what is true. So these are the three things we need to prove. If we can prove that these three works, it means that what this formula for each of these questions is true for those series. Okay, now so for the first question, let's say I'm going to solve that. We're given what 1 squared plus 2 squared plus 3 squared up till n squared to be equals to what n into n plus 1 into 2n plus 1 over what over 6. How do we solve this question? First, you have to say let P of n be equals to what, where you see n squared, which is equals to what, n into n plus 1 into 2n plus 1 all over 6. Okay, so after that, now say what, put what our P of n to be what P of 1, which now becomes what 1 squared. That means wherever you see n, you put 1. 1 squared, which is this, equals to what 1 into what 1 plus 1 into what 2 into 1 all plus 1 all over 6. Now it implies I have what, from this place I have what 1 to be equals to, this is 1 into 2 into what 2 times 1 is 2 plus 1 is what 3 into 3 all over 6. So if I divide, I'm going to have this as also what 1. So since 1 is equals to 1 and is also equals to 1 when I square this one, then it is true. So in that case, then P of 1 is what? P of 1 is what is true. Okay, that's for P of 1. Now let's now do the second one. So the first case is already completed. Okay, so for the second case now, which is put P of n to be P of k. Put our P of n to be equals to P of k, which now means whenever you see n, you put k in this series. So let's start from the beginning again. We have 1 squared plus 2 squared plus what 3 squared plus and so on plus what. In this case now we have what k squared is equals to what k into what k plus 1 into what 2k plus what plus 1 all over what all over 6. Now from here I'm done with this, so I'll just say what P of k is what assumed to be true. This is how we always make this conclusion for P of k is assumed to be what true. Then for number 3 we have what we have put what P of k to be equals to what P of k plus 1. It means wherever you see k, you should put what k plus 1 in this question. Now note, just like we have our say series of numbers or sequence of numbers 1 2 3 4, next one should be 5. Assuming my 4 is k, what will be the next one? It cannot be k again. It's going to be what k plus 1. Now why am I bringing this in? Is I'm bringing this in so we can know how we're going to do our k plus 1. Now we have 1 plus 2 plus 3 squared plus and so on plus k squared first, then plus what k plus 1 all squared, in which case we have this as what, put this as k plus 1, k plus 1, k plus 1 plus 1, that's k plus 2. In this case I have what 2 into bracket k plus 1. Okay, so when we expand that, I'm going to have what 2 into 2k plus 2. So 2k plus 2 plus 1 gives us what 2k plus 3 all over 6. If I put k plus 1 for k here, I'm going to have it as 2 into k plus 1. Expanding, I get what 2k plus 2. Then there's c plus 1 here, that becomes 2k plus 3 over 6. Now from this left hand side, Just as I explained there, 4, if 4 is k, next one is going to be what? K plus 1. That's why if this one is k squared, next one is going to be what? K plus 1 all squared. Now when you get here, you will now solve from the left hand side to get this. That's now what I'm going to do. You solve from here to get what? This, all the values you have here. Now how do I get that? Recall, from here to here represent our what? Our P of k. Just take note. Whenever you have gotten to P of k plus 1, you are going to write your P of k first, then then from here, our P of k represents year to year. It means that this is equals to this. So from here to here represents already what? K into what? K plus 1 into what? 2k plus 1 all over 6. Now, that's from here to here. What remains? Plus what? K plus 1 all squared. Now, I'll now prove that this, the sum of this, will give me this. Okay, now this becomes, if I find the LCM, this 6 here 1 times this give us this. 6 here 6 times this give us what? 6 into this, Abby. So if I bring out the fraction, what will I have? I'll have 1 over 6 into what? K into k plus 1 into what? 2k plus 1. That's for this one. Then plus what? 6 into k plus 1 all squared. Okay, so just like saying what is 1 over 2 plus 2? This becomes over 1. So 2 is the LCM. 2 here is what? 1 times 1 is 1 plus 2 here is 2 times 2 is what? 4. So that's like 2 into bracket this, which is the idea I used here to solve this. Now from here, I'm working towards what? I'm working towards this answer. That should be your mindset. I'm working towards this answer. So after I've brought out my LCM from this place, what will I do? Let me bring out what is common amongst them before I factorize. We have k plus 1, 2k plus 1. I have k plus 1 here. This one is squared. This one is just k plus 1 raised to power 1. So I can bring out what? K plus 1, to join 1 over 6. So in that case, I have what? 1 over 6 into what? K plus 1. What remains? I have k into what? 2k plus 1. Then plus what? 6 into what? K plus 1 raised to power 1. Okay, so let's write what we have left. I have what? K into what? 2k plus 1. Then plus what? 6 into what? K plus 1. From here, I now what? I now expand. When I expand, I have this as what? 1 over 6 into k plus 1. Now, in no case should you expand all this, before bringing out your common factors. First, bring out your common factors before expanding. So, in which case, what will I have? I will have this as what? 2k squared plus what? K, then plus what? 6k plus what? 6. Okay, now in which case, what do I have? This now becomes what? 1 over 6 into k plus 1. Okay, into, I can now add there first before I now find out what is common. Before I factorize, plus 7k plus what? 6. Now, I have this as what? 2 times 6 is what? Is 12. Okay, so 2 times 6 here gives us 12. So 4 times 3 will give us what? 12 also, to get 7. Sure you get. So in that case, I have what? 1 over 6 into k plus 1. Okay, into what? 2k squared plus 3k plus 4k plus what? 6. Okay, so from there, I have this as what? 1 over 6 into what? K plus 1 all into, if I group this and factorize, I'm going to have my answer as what? 2k, plus, okay, I'm going to have k common here, so that becomes, if k is common, then I'm going to have k, I'm going to have what? 2k plus what? 3, then all into what? 2 is common here, what remains? 2k also plus what? 3. Finally, this now becomes 1 over 6 into what? K plus 1 into what? K plus 2 into what? 2k plus what? 3. Now, that's my answer. If I compare that with what I have here, we can see that is what? Is the same thing. So since I attach my P of 1 to be true, my P of k to be assumed to be true, my P of k plus 1, and I got the answer that's at my right hand side here. Okay, then in that case, then I can say my P of k plus 1 is true. Okay, so that's for the first question. I don't want to go through it very well if you don't understand it, so you can. Now, for B question, we have what? 2 raised power n is greater than what? N. In this case now, let's see what we're going to do. So, first thing again, we try our what? We try our P of 1. Let's what? P of n be equals to what? Be equals to 2 raised power n greater than what? N in this case. So, what am I going to say? Put what? P of n to be equals to what? P of 1, which implies I'm going to have it as what? 2 raised power 1 to be greater than what? 1, which also implies that what? My 2 is greater than 1, and it is true. So, P of 1 is true. Now, if P of 1 is true, then let's move on. Put what? P of n to be what? Equals to P of k. Okay, which now gives us what? P of k to be equals to 2 raised power k greater than what? K. Okay, from this place. Now, finally, put what? P of k to be equals to what? P of what? K plus 1. Okay, which implies that I'm going to have what? P of k plus 1 from here to be what? 2 raised power k plus 1 in this case to be greater than what? K plus 1. Okay, in which case I now have it as what? Using indices to expand this, I must put my P of k in this P of k plus 1. That's why I have to convert it to this form, where I would transform this one to ordinary k. So using indices to expand this, I'm going to have this as what? 2 raised power k dot what? 2 raised power 1 to be greater than what? K plus 1. Now, this is 2 raised power k in my P of k plus 1. What is 2 raised power k in my P of k? That's ordinary k. So I can say k dot 2 greater than what? K plus 1. This is 2k, isn't it? So k plus k is greater than what? K plus 1. This is going to be the end of the proof. Now, how do we prove that this is greater than k plus 1? If I put 1 here, what will I have? I will have 2. I will have 2 here also. If I put 2 here, I'm going to have 4. I will have what? 3 here. If I put 3 here, I'm going to have what? 6. I'm going to have 4 here. So, it means that what? My k plus k is actually greater than my what? My k plus 1 in this question. Now, that's for this question. That's for question B. For question C, follow the way I did this question 1 or question A. Solve it and get your answer. Now, for question D now, for every positive integers n, prove that what? 7 raised power n minus 3 raised power n is divisible by what? By 4. How do we solve this kind of question? Now, I already picked out the questions that you would most likely see in mathematical induction, and I decided to solve each of them, so that solve a single question, of the different kind of questions we have in mathematical induction, so you can know how to relatively solve any question there. Now, in this case, how will I solve this question? For every positive integer n, prove that what? 7 raised power n minus 3 raised power n is divisible by what? By 4. Now, how do we solve this? This is the question. First, put what? Or let P of n be equals to what? 7 raised power n minus what? 3 raised power n. Okay, in this case, what will I have? Put what? P of n to be equals to P of 1, where I have P of 1 now to be equals to what? 7 raised power 1 minus 3 raised power 1, which is what? 7 minus 3, which gives us what? 4. Now, according to our assumption from the question, we have to prove that what? It is divisible by what? By 4. Now, from what I got after putting my P of 1, 4 is actually divisible by 4, which gives us what? 1. Therefore, our P of what? 1 is true. Okay, now in this case then, after getting your P of 1, what will I do next? Put what? P of n to be equals to what? P of what? K. To be P of k. For this question, after putting my P of k, I'm supposed to make a conclusion that what? My P of k is what? Assumed to be true. In this case, assumed to be true. Now, let's go back to this question. put P of n to be what? P of k. Whatever is n, you put k. So it means my P of k now becomes what? 7 raised power k minus 3 raised power what? K. That's the answer for that one. Now, in that case, my P of k is what? Is assumed to be true. Okay. Now, after getting your P of k, then put your what? P of k to be equals what? P of k plus 1. It means wherever I see k, I'm going to put what? K plus 1. Therefore, P of k plus 1 now becomes what? 7 raised power what? K plus 1 minus 3 raised power what? K plus 1. Now remember, I'm going to put I have to transform this, my P of k plus 1, in a way that I'll substitute my what? P of k into it. Now, note, there's a mistake I made when I was here. For this kind of question, since my question said it is divisible by 4, it means 7 raised power k minus 3 raised power k over 4 will give us a constant. What do I mean? If I say 8 is divisible by 2, it means 8 over 2 gives us what? Gives us 4. Abi? In that case, that's the answer. Now, if I say 4 is divisible by 4, it means 4 over 4 is equals to what? 1, isn't it? Now, assuming I don't know this constant, I can represent it with any variable, p, q, a, b, c, d, a to z, in that case then. So I could have said this is equal to what? 4d. How did I get 4d? This is divisible by 4. It means this minus this over 4 will give us a constant. Okay, which I don't know. So it means this is now equals to what? 4 times that constant, which is d. So this is what I'm supposed to do when I got here. Okay, which I just did now. Now, in this case now, to put our P of k plus 1, we have this. Convert this to what indices? That's 7 raised power k dot what? 7 minus what? 3 raised power k dot what? 3 raised power 1. This is 7 raised power 1. Now, transforming this P of k plus 1 to make us substitute our P of k in it is now what we're going to do here. How do I transform this to have P of k plus 1 inside? Because from here, 7 raised power k minus 3 raised power k is not here, evidently. I would like to do that, it will make it here. Pick this 7, pick this 3 raised power k, in between minus, then subtract and add. How do I mean? 7 raised power k dot 7 minus this 7 times 3 raised power k, this one. Then this one is still left down. 3 raised power k dot 3 raised power 1. Again, this is 7 raised power k dot 7 minus 3 raised power k dot 3 from our indices expansion of this. Okay, separate these ones. Add and subtract 7 dot 3 raised power k, that is in between and minus. So I've added it here. I'm supposed to subtract it from here. I'm supposed to add it to this one, 3 raised power k. So I'm going to add and subtract this such that if I add these ones together, I'll get 0. Okay. So now in this case, I bring these ones together. What do I have? What's common? 7 is common. What remains? 7 raised power k minus 3 raised power k. Minus, if I bring 3 raised power k out, what remains? It remains what? 3 minus what? Minus 7 from this right hand side. Now, this now represents what? My P of k. Okay, this represents my what? My P of k, which is what? 4d. So I'm going to have it as what? 7 into what? 4d. Okay, minus 3 raised power k into what? Minus 4. Okay, which now becomes 7 into what? 4d plus 4 into what? 3 raised power k, or 3 raised power k into 4, whichever it might be. Then from there, what's common? 4 is common, isn't it? If 4 comes out, what remains? 7d plus what? 3 raised power what? K. So it means this is a multiple of 4. From here, I have this to be a what? That if I divide this by 4, I'm going to get a constant. After I solve the question completely, I have this to be what? Multiple of what? 4. So this 4 has to be out to prove your answer. And P of k plus 1 in that case is now what? True. Okay, now just do what to go through the process very well. Find your P of 1, find your P of k, conclude that P of k is assumed to be true. In this case, you equate it to what? To what is divisible by, then times a constant, then you solve. When you get here, you will now manipulate such a way that your P of k appears back, so you can substitute your P of k into the question and you're good to go. Now for this equation that I said before, use this method to solve it. For this that I said before, use this one to solve it. This one's method to solve it. The one I just did now. And you're good to go in that case.